Okay, guys, so that the video wasn't short, I already kind of started to write some things down. But we're going to do this example. The formula that we're going to use in the video, in the C-4 intro video that I linked to in the calendar, that video shows you where this formula comes from, and why we can use it to give us the slope of the tangent line to a function at a given point. All right, so first, part A says give two phrases that are synonymous with the derivative of a function at a point. And so I just wrote that in already. So, so saying the derivative of a function at a point is the same as saying the slope of the tangent line to the graph at that point, which is also the same as saying the instantaneous rate of change at that point. So derivative, slope of tangent line, instantaneous rate of change, these are all the same thing. Okay, now part B says use the limit definition of the derivative to find a function that will give the instantaneous rate of change of the function below at any given point. Okay, so here's the formula. F prime of x, which stands for the derivative of f at x, equals the limit as h approaches 0 of this right here. Now guys, we're going to end up, when we use this formula, having two variables. We're going to have an x and an h. It's important to know that when we go to direct substitute 0, the 0 is going to be going in for h, because it's h that is getting closer and closer to 0, not x. Okay, so here we go. So f prime of x equals the limit as h approaches 0. And now this is f of x. So f of x plus h, I'm going to be putting an x plus h in where the x was. So let me use blanks for a second. So this is going to be 3 blank squared minus blank. All right, so this is the f of x plus h part. So this is f with blanks, and in where the x's used to be, I'm putting x plus h. Minus, okay, so this minus is that minus, so I gotta subtract f of x. So I definitely need parentheses here, all over h. And you know that whenever we do a limit, we try to direct substitute first. Well, it's h that's getting closer and closer to 0, but if I plug 0 in for h, there's 3 h's. And if I plug it in for this bottom one, I get 0 in the denominator. So this is where you go equals the limit, and then you just leave a blank. And then you do an aside. All right, so I'll do aside here. Where will I write it? No, I'll do an aside down here. Aside. Okay. So this is the limit input. The limit input is 3. Now let me do a bracket here because I'm going to expand the x plus h squared. I'm distributing the negative. Okay, and then this is all over h. Okay. Oh, and you can already see some things canceling. All right, this minus x and that minus x, those cancel. No, this should be a plus x. My bad, because I had to distribute the negative, so it'd be plus x. So now they cancel. And then on the inside here, guys, this right here, that is x squared plus 2xh plus h squared. That's what that ends up being. Yeah, and if you don't see how I got that, then just like do the distribution. So it's x squared plus xh plus another xh, so that's the 2xh, and then plus h squared if you distribute. Alrighty, so in the next line, I'm going to distribute the 3. So I'm going to distribute the 3 to this. So 3x squared plus 2xh plus h squared minus h minus 3x squared. Nope, that's a 6. Oh my gosh, I'm going crazy. And that's a 3 because I'm distributing the 3 all over h. So we're trying to get the h to cancel, this h to cancel. And if you look at the top, I've got right now 1, 2, 3, 4, 5 terms. If they all had a factor of h, then I could factor out an h in the top, and then that would cancel. But they don't all have an h. Because this first term and that last term, they don't have an h, but they cancel. So those cancel. And then we end up with 6xh plus 3h squared minus h all over h. And now, so this h we want to cancel. We have 3 terms. They all have a factor of h. So now you could actually factor out an h. 6x plus 3h minus 1. And now this h cancels. Okay. And now that you got the h to cancel, you could take this and put it back up in the limit. So 6x plus 3h minus 1. Okay. Now you do direct substitution. So the limit is going to go away. There's going to be no more limit. And so h is getting closer and closer and closer to 0. So this h, we're going to put a 0 in for. So this is 6x plus 3 times 0 minus 1. Okay, so therefore, we've got f prime of x equals 6x minus 1. So this here is a formula that will give us the derivative. It'll give us the instantaneous rate of change at any point. All right. If you want to know for this graph f here, what's the instantaneous rate of change at x equals 1? Well, you would plug 1 into this derivative formula, and then that would give you the instantaneous rate of change at that x value, which would be the same as the slope of the tangent line at the x value, which is the same as the derivative at it. So now part C says to use the equation that you got from part B to find the slope of the tangent line to the graph at x equals 16. So I'm going to go f prime of 16 equals 6 times 16 minus 1. This is equal to, I'm pretty sure from before that's 95. 6 times, yeah, it's 95. So guys, imagine that. The slope of the tangent line is 95. That's a super steep slope. So that means that the graph is like really steep at x equals 16. All right, guys. So there's that. So on your practice, you'll just practice this process a bunch of times, and it should get very fast. If you say to yourself, oh my gosh, this is so long, this is taking me forever, that means you need to practice more. This should be a fast process. And if it's not, then it means you need to practice more until you're fast at it. Okay, guys, I will talk to you later. Bye-bye.